Hello and welcome to another section in further mathematics. In this section we'll be looking at the topic logarithms of numbers. We're looking at logarithms of numbers. Now when we talk about logarithm of numbers, there are certain things I really want us to go into detailed analysis. But before that, let us do a quick review of our previous lesson. Okay, welcome back. Now, when we talk about logarithm of numbers, the best thing that comes to our mind is index, which have to do with the powers. So index, like if I have 2 raised to power x, now this is in the index form, and the logarithmic form. Now, the logarithm to a base a of a number p is the index x to which a must be raised to be equal to p. So this is what they are trying to explain. If you have p equal to a raised to power x, then x is the logarithm to base a of p. We write it as x equals to log a base p. So this is to tell us that when we have 5 raised to power 2 equals 25. Now it's the same thing as log 25 base 5 equal to 2. So the power, or you call it the index here, is serves as the solution to the logarithm, while the standing term serves as a log number, and the number that serves as the lower term raising the power serves as the base of our logarithms. So you can as well apply it here. The relationship log a p is equal to x, and ax are equivalent to each other. So they are trying to tell us that even if you place this number 5 raised to power 2 equals 25, or you put it in this form log 25 over 5 equal to, they are all the same thing. So you use the sign of equivalence in specifying them, and that's how it works. Now the first thing we have to do here is we have to convert from index form to logarithmic form, and that's what we're just doing. Convert from index to logarithmic form. So here what we'll be having here is 2 raised to power 6 to be equal to 64. That's a. We are converting all this into logarithmic form. We'll be solving like 3 equations. 25 raised to power half equal to 5, and c will be having 4 raised to the power minus 4 to be equal to 1 over 256. Now let's convert them into logarithmic form. So we now have number 1. Remember what I said, the power serves as the answer, the standing term serves as a logarithm, while the base serves as the exponent raising a power. So we now have this is equal to log 64, the standing term. Now 2 raised to power 6, I said the power, that is what you have at top, serves as the answer, while 2 is the base. So this is equivalent to this. Now if you want to apply it here, you now have log, remember this is the log 5, now equal to, remember the power is serves as your answer, the solution 25 serves as your base. So if you do log 5 base 25, you have your answer will be half. Now in this other context, you know, we have log of 1 over 256 to base 4, and it's equal to minus 4. This equals minus 4, and that is the value. And in the other way around, we can still convert from logarithmic form to index form. Now if you are converting from the logarithmic form to index form, for example, if you have the value of log, let's call this a, log 128 base 2 equals 7. Now this is equal to, is the same thing. Remember, this raises the answer. It becomes to 2 raised to power 7 equals 1, 2, 8. This is the index form. I can decide to give you, let me give you the second part, B. I can give you log 0.01 base 10 to being equals minus 2. So if you want to convert it to index form, remember, you raise this 10 raised to power minus 2 is equals 0.01. So this is the conversion of logarithm. So when we talk about finally, I want us to talk about for today's class, let's talk about the laws of logarithms. Let's talk about the laws of logarithm. Now, if we are talking about the laws of logarithm, we say, for example, let p be equals b raised to power x. Then, just like what we did, we now say then log p base b is equals to x. This is the first law. This was what we used. Remember, the power is always here. The log itself is a standing term, and what you have as a base here serves as the base of the logarithm. Now, the b part, the second law of logarithm, if we have log b p q, these are constant terms that we need to memorize so that we learn how to apply them when we are solving logarithm. Is the same thing as log b p plus log q b. So it's the same thing. When you have the product, just like what we have in indices, you convert it to addition of logarithms. Then number 3, remember in indices, when we had multiplication, we converted to addition. When we now had division, it became subtraction in indices. Now in logarithm, the same thing is applicable. If you have it this way, p over q, the same thing that happens, that played in indices, you now have it as log b p minus log q b. Is playing out the same like what we had in indices. And the fourth law, that is d, that stays log p raised to power n base b, is the same thing as when you have raised to power, the log becomes n log p base b. So the n at the top comes to the back. They now have your log p base b here. This one of the law. But there's one unique law in logarithm. We should know that log b to base b is equal to 1. Log 10 to base 10 is equal to 1. Log 100 to base 100 is equal to 1. Even log z to base z, log to its base, if the power of the log and the base is the same, then the answer is equals 1. Then lastly, that is our f value. We are rounding up the laws of logarithm, and we'll use these laws in solving so many questions. The log of 1, the logarithm of 1 is 0, no matter the base. If you have log 1 base 100, your answer is 0. If you have log 1 to base 50,000, your answer is 0. No matter the base of the logarithm, log 1 is equal to 0. I would like to say a very big thank you for being part of today's lesson. But in order for you to maintain consistency in your knowledge of logarithm, I would like you to memorize what you're seeing right in front of you. And please take the test that will be appearing shortly on your screen. At least this will help you to check your level of proficiency when it comes to logarithm. Do well to use the lesson notes on this platform for better information on the topic we've discussed.